Hello students, welcome to Math Fam. So our topic today it's going to be 3D solids and how do we calculate the surface area and volume of 3D solids. Now you know that every 3D solid is the combination of two-dimensional figure here. Faces will be the two-dimensional figure. So that is why you should be aware about areas of 2D figures, right? Then based on the area we are going to take here surface area of 3D solids. There will be common some solids and then prism and pyramid also you will take it. Then volume and capacity. What is the difference between volume and capacity? We'll see that. And again we are going to take the different types of shapes when we are taking calculating the surface area or volume. And after that conversion is very important because whenever you are taking mensuration topic, this topic, you should know how do we convert one unit into other unit, and after that we are going to take the exam based practice question. Now, in this exam-based question here in IB exam, the in extended math here, the weightage is going to be less. It can be here 7 to 10 marks for extended math, and if you are having standard math, then the weightage is going to be more. Okay, and most of the time, this topic here, standard math, it can be 15 to 20 marks, right? So, what happens here? This topic, many a times you will see, will be integrated with geometry or trigonometry or sometimes investigating pattern also. So here these are the questions we are going to discuss here, which is from the past paper. So this is the formula list where all the formulas of 2D figures it's given here. So first thing, the basic figure is rectangle. You know it is always length into width or length into breadth. Now what is going to be the area of a triangle? It is always half times base times height. But there are the other formula also that you need to remember here. If I'm taking here area of a triangle, you need to always remember that we can take it here as half AB sine theta, where A and B are the two sides of a triangle where the theta angle is the included angle, right? So if A and B are the sides, so what is the angle between A and B? This is called theta. So we can take it here half AB sine theta generally because this will be integrated with trigonometry also. So that is why that time we can use this because every figure you may not have height of the triangle, right? So if it is acute triangle, then our height is going to be in the middle here, the distance from a vertex to the opposite side. If this is the obtuse triangle, that's why the height is going to lie outside the triangle. So either you use half base into height or half AB sine theta. These two formula you have to remember to calculate the area of triangle. Then area of a parallelogram, it is always base into height. So base can be anything which is one of the side and the distance between the parallel side. If I'm taking here this as base, then what is going to be the distance? This is going to be the distance between two parallel sides. So whichever parallel side is the base, the height, the perpendicular height between those two parallel lines should be there. Other than that, you have to remember here one more formula. If I take here, this is for parallelogram. If I'm taking here, the two sides are A and B here, right? If base height is not known, if side is A, this is side is B, and the included angle is theta. Right, so here you can take here area of this parallelogram here. Area is always occupied space. So AB sine theta, which is double of the area of triangle, right? So area means this is occupied space. This is also what is going to be the area. I can either I take base into height or AB sine theta. Either formula you can use. After that, trapezium, area of trapezium is always sum of parallel side, 1 by 2 sum of parallel side and the distance between those two parallel sides. So this formula also you have to remember. Then circle is also a 2D figure. What is the area of a circle? Circle is always pi r square. Now, area of a sector, if I'm taking here area of a sector, sector is a piece of circle because here you have taken circle, so this is a piece of circle. This is called, the sector is the area enclosed between two radii and one arc. Now here this area, if I need to calculate, I must know the theta angle between those two radii here. So theta by 360 pi r square. Why do we take it here? Why do we take out of 360? Because it's theta, central angle is theta out of 360-degree angle of pi r square. So it's a fractional value that we use it for sector. Other than that, you should know here, because for the regular hexagon, how do we calculate the area of a regular hexagon? Because when you are taking a prism and pyramid, you are going to use it. right? So if I'm taking here regular hexagon means all the sides are equal, right? This is regular hexagon. Now, how do we do it here? All the sides are equal. If I'm taking the side length as A, so all the side length here, if I take it as A, then you know that if you draw a circle, it will pass through all the vertices. So if I take this, you can see that here I can divide it into 6 congruent triangles here. Now here, because it's a regular polygon, here you know that the central angle, each angle is going to be 60 degree, and when you will draw a circle, it will pass through these vertices, right? So here, if this is 60 degree and this is a circle, these two are going to be equal. So each angle is going to be here 60 degree. So what is going to be our area of each triangle? Here, each triangle, you can take it as half AB sine theta formula. So here A is nothing but, because it's an equilateral triangle, each side is going to be A. So it's a half times A square times sine 60. If I take it here, then you know that this one, because there are 6 triangles, so area of hexagon, you take it here, area of hexagon will be 6 times area of each triangle, which is half times A square sine theta, which is sine 60 degree. Now, if you remember this, just area of triangle times 6, because there are 6 congruent triangles. So these are the 2D figures area that you have to remember. Now here we will see how do we derive the formula of surface area and volume of 3D figures or solids, right? So it's written here, whenever the solid is there, it is the combination of plane faces. That's why we have seen how to calculate the area of 2D figures. Now what is written here, the surface area of a three-dimensional figure with the plane faces is the sum of area of its faces. Plane faces means it can be square, it can be rectangle, any plane figure. They can be curved face also. We'll see that with any curved face, we can convert it into 2D face, and then we are going to take the area of that 2D figures, and we are going to add the area of all its faces to get the total surface area. Now, whenever you are talking about the surface area, there can be total surface area, there can be lateral surface area if the faces are made up by the straight line, or there can be curved surface area if the figure or solid is having any curved surface where it's not a straight line, it's curved. Sometime LSA and CSA we use it for both curved surface area. Now, so surface, for to calculate the surface area, we should know the net which is required to make the figure. Now here, if you'll observe here, all these are the nets. So this is the first figure, it is cube. You can see here, if you open the cube, it looks, there are 6 faces, 1, 2, 3, 4, which are square, and the top and bottom, which is these two inner sides. So each, because it is a cube, it is, everything is going to be L, length is L, width is L, and height is also L. Or I can take it as a S and S and S here. Right, so automatically, because each one is square, it will become S square, S square, S square, S square, and S square here and S square. So whenever we are calculating the total surface area, we'll add the area of each of the 6 faces. Now, what is the, that is total surface area. Then what will be the lateral surface area? Lateral surface area is surrounded or the 4 sides excluding top and bottom of any 3D figure. So here, if you exclude the top and bottom, there will be only this one, you have to remove it. Then the 4 faces which is making the figure, surrounding of that figure, it's called lateral surface area. Similarly, the second figure, if you will see, it is a cuboid and its net. To calculate the total surface area, we need to add its 6 faces area. So here you can see that the alternate faces are identical here, because it is length, width, and height. If you will see here, this is the base, which is always LB. The area is going to become here LB, right? So here, this also, the top here, ceiling is also LB. If you are sitting in a room, cuboidal shaped room, the basic, the floor is going to be L into B, and the ceiling is going to be L into B. And then here, length into height will be the area of this face. Then it will be here, width into height. This again will be length into height. This is width into height. And to calculate the total surface area, if we'll add everything, we'll get the total surface area, which will be 2LW plus 2LH plus 2WH, and 2 can be taken common. right? So this is the way we calculate the surface area. We'll see all these basic figures. How do we calculate the surface area and volume? But before that, what is the meaning of volume? What is the difference between volume and capacity? Now, volume means the volume of a solid is the amount of space it occupies. How much, if I'm having a 3D figure, if I'm placing it, how much space it occupies, or if I'm making that solid, how much material is used to make that solid. If it is dense, that's called volume. Amount of space it occupies, or material used to, if it is not hollow, material used to make it solid, make that solid, right? Sometime it is a hollow, so we'll have the volume of the hollow shapes also, and sometime it is a solid shape, so we will see in both the cases how to calculate the volume. Then capacity means if the container is can hold some amount or some quantity of fluid or gas. The capacity of a container is the quantity of fluid or gas used to fill it. So that means it is hollow. If I'm having a cylinder or a cube or cuboidal tank is there where the water can fill. So we will say what is the capacity of that cuboidal tank. That means how much water is going to fill inside that tank is known as the capacity. So we are having two different terms, but the formulas are going to be same for volume as well as capacity. So let us see here what are the basic formulas, basic figures, then we'll go for prism and pyramid. So here whenever we are taking Q first you should know the total surface area because all the sides length, width and height are same. So you know that there are 6 faces, so you can write down 6s square, whereas lateral surface area or curved surface area will be area of 4 squares. Now similarly here if I'm taking the volume of this cube, it is always area of base into height. Now the base area is L into B. So and height is H. So L and B they both are S and the height is also S. So it will become SQ. So these formula, basic formula you have to remember for these common figures, right? So here after that when we are having cuboid, what is going to be the total surface area of cuboid here? If I'm taking here, there are two faces which is 2LB plus here 2LB or LW also you can write on breadth or width, anything you can write on here, plus 2LH, write down 2 WH, right? Now 2 is common. So here there are three formulas. Here also you are going to learn three formulas. 2 is common. So length into width and length into height plus width into height. That's the total surface area. Now if I'm talking about the lateral surface area or curved surface area of this cuboid, you know that you have to exclude the bottom and the ceiling. So what is left here? It is going to be 2LH plus 2WH. Both here 2H is common. So length plus width you can take it as a lateral surface area. Similarly, if I'm taking the volume here, volume of a cuboid, again area of base is going to be LB into H. Area of base or area of cross section into height. You will see the cuboid is known as a rectangular prism also. So there also you will see why we are reaching to this formula. Now what is the next basic figure here? You will see cylinder here. Now this cylinder, how do we take the cylinder? Cylinder get, you will always get a rectangle and the top which is circular and bottom it is circular. Right, so whenever we open a cylinder, we get a rectangle. Now, what happened? How do we calculate? You know, because it's a circle, so the radius will be r here. So, if I'm talking about the curved surface area, that means here area of only this rectangle, the curved part excluding top and bottom, right? That's called curved surface area. How do we get here CSA, curved surface area? You can see here this is nothing but length and width. Now this length, if you roll it, it will become the circumference of a circle. You can see that this is the circumference of the circle. If you open it, it becomes the length and the height is nothing but width. So what is going to be the area? L into W, which is nothing but 2 pi RH in terms of radius and height. If I'm taking here total surface area, it will be CSA plus area of two circles, because you can see that the top is also circle and bottom is also circle. So if I'm taking the total surface area, I can take 2 pi rh, and area of each circle is pi r square, so it is 2 pi r square. So here 2 pi r, and then you can have r plus h. So this is the formula. Volume is again area of base into height. So what is the base here? The base is circular. This is the circular base, and base is pi r square area times h. This becomes the volume of a cylinder. Cone, whenever we see the net of a cone, you always get it's a combination of a sector. This is nothing but sector and circle. So here if you will see, circular base is there, and if you open this, this is nothing but a sector. The area between two radii and the arc of a circle is known as sector. Now how do we calculate? You know that here if I'm taking here curved surface area, that means what will be the area of this sector? This is called here radius of the base. Then this is called slant height. Sometimes we write down as L also. This is nothing but slant height. One is going to be perpendicular height. What is perpendicular height here? H, which is perpendicular to the radius. That's called H. That's why we can't take it as H. S represents slant height. So curved surface area, there is a way you divide this into infinite small triangle, and you will take half base into height, and if you add it, this becomes the circumference, and you get here pi r s, right? Pi r l or pi r s, where r is the radius of the base and s is the slant height. There is a Pythagoras theorem you can apply, because there is a relationship between perpendicular height, slant height, and radius. So how can we take it here? Because this is called right cone also. Why do we call it as right cone? Because the vertex of the cone and the center of the bottom, it is making 90-degree angle. So what else you have to remember? S square is equals to h square plus r square. We're using Pythagoras theorem, and you use this Pythagoras theorem in many cases to calculate any unknown length here. Then using this, if I'm taking here total surface area, it is going to be CSA plus area of circle, right? If it's a total surface area, what is going to be area of circle? CSA is pi r s. So you take here pi r s plus area of a circle is pi r square. What is common in both? Pi r. You can take it here s plus r. So this is the total surface area. Volume, how to calculate? Because you will see that now the right cone is nothing but a pyramid. Whenever we have a pyramid, it's a circular pyramid because the base is circular. So whenever there is a pyramid, we take the formula as 1/3 area of base into height. Height means 1/3, always area. This is the formula of any pyramid, right? Volume of the pyramid. So 1/3 the base area, base is circle, so it is pi r square h. After that, the next figure we call it as sphere. Now, whenever we take sphere, it's a solid ball, you can take it. Now, how do we take it here? The curved surface area and total surface area, it is the same thing. If I take a thread, I put around this sphere, and if I take the same thread, you will see that it is going to fit into four circle of same radius as here. These are going to be four circle of having the same radius. So that is why whether it's a CSA or TSA, it is same, which is 4 circle area, means it will be 4 pi r square. So this is the way to remember. Whenever we are having a sphere, sphere is a solid figure, 3D figure, whereas circle is a 2D figure, and we know that how many such faces are there? We do see only one curved face here, right? So that's why TSA and CSA, it is 4 pi r square. Then other than that, here if I take the volume of a sphere, you have to remember 4 by 3 pi r cube. If I'm having a hemisphere, if I draw the hemisphere, if I'm taking one half here, this is nothing but radius. Now this also it is going to be radius because this side also it is r only. Now you can see that now there will be curved surface area of a hemisphere if I take it, because you cut sphere into two equal half, right? And total surface area was of a sphere was 4 pi r square. So hemisphere means only this part, it will be half of the sphere, which is 2 pi r square. Now, what is going to be the total surface area of a hemisphere? So, you will take this part, which is already 2 pi r square, and the top is also circular in shape. So, that's why 2 pi r square, and for top, which is also a circle, the total area will be 3 pi r square, not 2 pi r square. This formula, you don't get it, you should remember how to derive from the sphere. Now, what is going to be the volume here? Because the hemisphere is half of the sphere, so volume here it was 4 by 3, so it will be half of 4 by 3, half of the volume of sphere, which is nothing but 2 by 3 pi r cube. Now, these are the different types of prism. How are you going to calculate the total surface area here? So, if you will see, first you should know how to identify the prism. Now, prism, whenever you are having it, the cross sections are going to be same. That means there will be two identical faces. If you will see, this is called triangular prism, because here if you will see this triangle and this triangle, face is called here the cross section, and the three vertices of the cross section, it is joined by the another three vertices of the respective triangle. So this is always, this part is called cross section here, cross section, and this length is going to be the same here, right? Here if you will see, so whenever we are having a prism, other than here cross section, you will see there will be rectangular faces here. So how many rectangular faces you see here? One face in the broad bottom, one face at the back, and one face on the side, right? So there are three rectangles and two triangles. So total surface area is again going to be sum of area of its faces, its 2D faces, right? Two dimensional figures here. And whenever we are having any prism, the volume is always here. Its area of cross section into length, because the length is going to be the same length, or some cases it can be height also if it is kept vertically. Here also, if you will see, what is the cross section here? This rectangular faces are known as cross section here, and if you will see, there are four vertices of rectangle that is joined by the straight line, so it is a prism. Here it's a square prism because the face is square, which is joined by this length. So again, area of square times length is going to be the cross section. Here if you'll see, this is the pentagonal face cross section here, which is identical, which is, and the four, those corresponding five vertices are joined by these length, which is nothing but the height of this pentagonal prism. Similarly, hexagonal prisms, how do you get it here? Hexagon, here it will be regular hexagon. If you take the area of hexagon times this height, we'll get the volume of prism. Here if I take, there are different types of pyramids. Here, all these shapes are known as pyramid. Pyramid, based on their base, we call it as here. Which kind of pyramid is this? Now, at the top, this is called vertex, and this is called base of the pyramid. Now, base shape, if you will see, it is triangular in shape, so we call it as triangular pyramid. Now, these three bottom vertices, base face vertices, are joined through the vertex here, right? So always there will be height of the pyramid also. What is the meaning of height of the pyramid? From here at the center, if you take this, this is perpendicular height, that's called height of the pyramid, and this is called base of the pyramid because base is square. Now base is having here four vertices, which is joined by the vertex. So there are four triangular faces and one square face. Here this is, if you will see, it's a pentagonal pyramid. This area Here this is called base of the pyramid. Now again, what is going to be the height? If I'm taking the height, it is going to be always the perpendicular distance from the center here in the middle of the base to this is the perpendicular height of the pyramid, right? So here this will be perpendicular, that is going to be height. So how do we calculate surface area? Again, here area of base and those triangular faces. Now pyramid, there is a specific way to calculate the surface area that we will see, but the total surface area is again here the sum of area of all its faces. We will get the total surface area. And volume, what do we take? Because it is a pyramid, it's always 1 by third times area of base times height of the pyramid, area of base times height. So now, other than that, you should know sometime you get hollow solids, and here you have to calculate the volume in most of the cases. There can be surface area also, but most of the time you get volume based question. So, which kind of question you get it here? If I'm having a cylinder which is having some thickness, or if there is a cylindrical pipe of some thickness, you can see this is called thickness of the cylinder. Now, if I need to find out how much amount of metal is used or plastic is used to make this, that means we need to calculate the volume. So whenever we are having here, you will always have here inner cylinder, that means smaller cylinder which is inside. You can see here there are two cylinders. This is called inner cylinder here, and this is called outer cylinder. So the because we can't take both the volume, there is it is empty, it's a hollow from the inside. So first you will take always, if I take inner cylinder radius as small r and outer cylinder radius, if I take it as capital R. So if I write down here small r and this part here, if it is capital R, this one, whenever you are having this volume of, we need to find out how much metal is used, then you always take here volume of outer cylinder, right, minus volume of inner cylinder. What is going to be the volume of outer cylinder? You know that the volume of cylinder is pi capital R square h, because the height is of this cylinder is going to be same. I can take height as h minus pi r square h, r square minus small r square. I'm having here a sphere which is, take it like this, then that means how much material is used to make this hollow sphere. Then again here you can take 4 by 3 pi r cube, which is going to be, this is going to be your outer radius, capital R. Inner radius, we can take it as small r minus 4 by 3 volume. If you take it here, I will get it here r cube minus r cube. Similarly, you will have it here for hemisphere also. If there is some thickness of this hemisphere, if I get it here, then again for this also, how much material is used in this thickness. So again you are having inner radius as r, outer radius as capital R. So it will become here 2 by 3 pi capital R cube minus 2 by 3 pi R cube. So this is the way you can derive the formula based on figure. You can have cone also. Okay, so cone also you'll take outer volume minus inner volume. Now, how do you do the conversion? I'll tell you the basic things that you have to remember so that you can apply that for any kind of question. So, first thing, whenever I start, 1 meter is 100 centimeter, or if I take 1 centimeter as 10 millimeter, or if I take 1 kilometer as 1000 meter, all these you take it for length, width or height. That means it is one dimensional. But whenever we take here area, that means we'll have it here square unit. So 1 square meter will be how many square centimeter? You just need to do here both sides squaring, because square a meter will become square meter if you do squaring both sides. So this one will become 1 square meter, because 1 square is 1 only. but the right hand side will be 100 square centimeter, which is nothing but 10,000. Here if I'm taking 10,000 square centimeter, so 1 meter square is 10,000 square meter, not 100 square meter, right? Similarly here, if I'm for the length 1 centimeter is 10 millimeter. If I need the for the area, it will be 1 square centimeter. So right side also it will be 10 square millimeter square, which is nothing but here 100 millimeter square. So if I have to do the conversion 1 square centimeter, I should remember it is 100 millimeter square, not the 10 millimeter square. Similarly here, if I'm having 1 kilometer square, then it will become 1,000 square meter, which is 1 kilometer. So what you need to remember here, I just need to do the squaring both sides, then it is very easy to remember here, right? And other than that, same thing you will apply, because you can have 1 kilometer is how many centimeter, so you will just multiply here, it will become two more zeros and you can do squaring both sides. Then what happens for the volume? Now for volume, you know that it will be 1 cubic meter. Now cubic meter, how will you get it? When you will do in the basic length unit, if you cube both the sides. So what do we get it here? 1 cubic meter will be 100 cubic centimeter, or 1 cubic meter is 1 followed with here 2 threes are 6, 6 zeros, right? 5, 6 zeros. That is going to be here 1 million cubic centimeter. So if it's a cube, then you will do cubing both sides. If it's a square, means area, you are going to do squaring both sides. Then other than that here, this is for area, that is for volume. Now these are the basic unit. You can use any other unit in the similar manner. Similarly here, 1 cubic centimeter will be 10 cube millimeter cube. Or if I take it here, 1 cubic centimeter is 1,000 millimeter cubic millimeter. Then after that here, 1 cubic kilometer will be equals to here 1,000 here cubic meter, right? So same thing here, if I'm taking here cube, I have to take 1,000 three times, so 6 9 zeros will be there cubic meter. But sometime whenever we are talking about capacity, now, capacity means it is going to hold something, and whenever something needs to be hold means you always take it in liter, especially the volume part, you take it in the liter. So, other than this, the basic unit you have to remember whenever, so you take it as millimeter or liter, right? So how do we take it here? 1 liter is always here. So the basic unit here, 1 liter is 1,000 milliliter. That you know. But how do we relate? And similarly here, this is nothing but 1 liter is 1,000 milliliter, and similarly 1 kiloliter here, 1 kiloliter is 1,000 liter. Now this is the basic unit. Now how do we do the conversion? Because generally when we are talking about the volume, we get it in cubic unit. So you need to remember here, if I'm taking here 1 cubic meter is always 1,000 liter. That means if I'm having a cube of length 1 meter, breadth 1 meter, height 1 meter, then it can hold 1,000 liter of water. Similarly here, 1 liter is going to be here 1,000 cubic centimeter here as 1 kiloliter as well. So this is the basic thing that you have to always remember. This 1,000 milliliter. So how can you relate cubic centimeter and liter? From here I can write on here 1,000 milliliter is 1,000 cubic centimeter, right? So 1 milliliter is going to be 1 cubic centimeter. So this also you can remember. One more thing here, you can remember 1 here. I'm just adding one more thing. Sometimes they ask here, 1 hectare is 10,000 meters square. Now here if we see surface area of pyramid, cones and sphere, each one is having different method for finding its surface area. We have already seen for cone it is pi r is plus pi r square because the area of sector plus area of the base. Sphere also we have seen it 4 pi r square is the total surface area. But this is a pyramid. Pyramid will have one base will be there and the side faces are always triangle, and sometime I need to calculate this is called slant height, right? So slant height, if I need to find out, this is perpendicular, right? How do you find out this? That means we need to sometime use Pythagoras theorem to find out, because wherever you see 90-degree angle and if there is a right triangle, using trigonometric ratio or using this is using trigonometric ratio or Pythagoras theorem, I can find out the unknown length. How do we solve this question? It says that find out the surface area of this rectangular base pyramid. So first, what do we take here? If you see this, because the area of the triangle, there will be two different ways here of this triangle, and the opposite triangle will have the same area. Then this front triangle area and back triangle area will be same. So first thing, let us, what is going to be here? Again, the TSA or total surface area will be equals to here base area, right? Base area plus 2 times area of triangle. One, if I take it here, one triangle is the front side and this is two on the side triangle. So two times here area of triangle. Now here if I name it, it's easy to take it. It's a B, C here and A, C, D. So here two times here I can take triangle A, B, C because front and back side it will be same, and here it is triangle A, C, D. Now, how will you calculate? Because here the base is there, but the height is not there. Slant height, this is 10 centimeter. Now, what is it? Will be exactly in the middle. So, this part, if you will take it here, it will be exactly in the middle. So, it will be 4, and the height is given as 6, right? So, what is going to be if I say it as S1? So if this is S1, your S1, which is your slant height, because we have seen that that's called slant height, is going to be using Pythagoras theorem, because if you see it is a hypotenuse of the right triangle will be 6 square plus 4 square, and if I'm taking that 6 square plus 4 square, you get it as root 52, and if you simplify this you will get here 2 root 13 centimeter. Now you got this as this. So what is going to be here? Area of triangle 1 here, area of front triangle, we can take it here, or here triangle ABC. It is going to be half base into height. Base is 10 and height is 2 root 13, where 2 gets cancelled. So we are getting here 10 root 13 square centimeter. Later on, we will substitute in 1 to get the total surface area. Now, similarly, I need to find out the height, because here, if you will see, this is slant height 2, right? This is S2 because the front triangle and side triangle. So, what you will get it here, if you want to take it here, you are going to get it like this. This is your S2, right? This is again 90-degree. Now what will be this length? If you take it, it will be half of, because it is exactly in the middle, it will be half of 10. So what is going to be my triangle here? If I'm taking that triangle, this part is 6 only. Here it will be half, which is half of 10, which is 5, and this is your S2. So what is going to be here again? If I take it here, S2, which is the slant height of the side triangle here, side will be root 6 square plus 5 square, if I get it here, which is nothing but here root 61 centimeter. Now 61 is a, you can't do the further simplification, it is a prime number. Then area of side triangle or side triangle you can write down here, which is triangle ACD. Then again, now the base is 8 and height is slant height is 61. So it's a 4 root 61 centimeter square. Total surface area of base 10 times 8 because L length into width. This is there plus 2 times 10 root 13, which is the area of front triangles, front and back. That means times 2 plus here 2 times 4 root 61. Do this simplification, 214.59 square centimeter, which is 215 square centimeter if I'm taking here three significant figures. We are taking this volume of pyramid formula. It's 1/3 area of base into height. Some cases height is also missing. So you can use trigonometric ratio or you can use Pythagoras theorem to find out the missing length. Now height is already given, it's a 6 centimeters. So I can take it here 6, which is 3 ones are 2s are, it is going to be 160 cubic centimeters. Now this is the past paper based question. If you'll see, the weightage is given 9 marks because it's a standalone question from extended math paper. Sometimes mensuration is integrated with other topic and there will be more weightage. So generally extended math you'll have 8 to 10 marks allotted for this. So what is given here in the diagram below shows a square based pyramid of height h with 4 equilateral triangle of length 24 centimeters. So first you have to observe the pyramid here, interact with the slider to see the different faces of pyramid. It's given here, it's an equilateral triangle. So each angle here will be 60 degree, 60 degree and 60 degree. Now if I see the height, there are two things you can do it here. Either I can take here slant height, which is in the middle, and if I get here side one, then this is going to be, because it's the same half of 24, that is going to be 12. If I'm having here, say if I'm having S1, right? So we know that from here, if you see this, I can take it here, S1 square is equals to H square plus 12 square using Pythagoras theorem, right? If I take here triangle here, if I write on AOB, right? So here using triangle AOB, I'm just telling you the different ways to identify. Later on you can follow any of the method. Now what happens here, because I know each angle is 60 degree. So look at here, because if this is 60 degree, right, the total equilateral triangle area you can get it, and this is your side length here, slant height, and again I can find out the slant height using trigonometry, using area of the triangle also, because all these four triangles are equilateral triangles. So to find out the S1 I can use here area of triangle also. So here what can I do it here, you know that half AB sine theta, right, is equals to area of triangle, right, area of triangle. Now here what is going to be the area of triangle, I can take it here half AB, this is half AB sine theta. If I take it here, I know base and AB, they both is 24 times 24 times sine 60. That you can equate with half base into height, which is your S1. So in this way you can get S1, because here there are two unknown values. You can't use directly Pythagoras theorem. So you must have here S1 value, which is slant height, then only you can calculate. Now here what base, we know that it is 24. So what will be your S1? S1 is going to be here, if I take this, it will be 12 times 24 times sine 60 divided by 12. If you do this, you will get S1 and then you can use Pythagoras theorem to get the answer. What is the other way? One more way is there. If you will see here, if I join this, look at here. I can join this height with one of the corner also, because here if you will see, look at here, the base diagonals are going to intersect at the center here, which is O, right? Now here, how do we get this length here? If I'm taking here OC length, you know that here you can use again Pythagoras theorem to find out. here this total length, which is BCD, if I take it. How to get the CD length? You know that the diagonals are equal in length. So how to get the diagonal? Here CD length will be square root of 24 square plus 24 square. If I do this here, 152. This is the value, and 24 root 2 centimeter. Now what is going to be the OC length? So this is one method you can use it. This is the another method. So OC length is going to be 12 root 2 centimeter. Now if you are having here 12 root 2 centimeter, this is already 24 centimeter. Again here it will be, how can you get it here? H square plus 12 root 2 whole square will be equals to 24 square. So h square is going to be 24 square minus 12 root 2 whole square, and h will be root 288, here 12 root 2. So this is going to be your height. This is the second part. If you see here, it says here, find out the volume of this pyramid, give your answer to the nearest integer. Here volume is going to be equals to here 1 by 3 area of base times height. Right now, what is the base area? Because it's a square, square area is S square. You will have 24 times 24, which is 24 square, and height you got it as 12 root 2 in the 3258.34 cubic centimeter. But we need to write down as a nearest integer, so it will be 3258 cubic centimeter. This is C part. The square base pyramid is used as a plant holder as shown in the diagram. Soil is added to the plant holder until it reaches 75% of the volume of the plant holder. So here if you see the height, what do we need to find out? Height of the soil. Now if you'll see, there are two pyramids. Till here height, if I take it as h1 and the actual pyramid where the height was 12 root 2 centimeter, that we got it in the first part. Now if you remember, how do we relate the scale factor and volume? Here I can take here volume of soil, right, by volume of holder, because volume of holder means it is going to be the total volume. I can take it as here till what is the height here? Height is h1 and here it is small h whole cube. This is the relationship between volume and the scale factor. Now, if you substitute the values here, this cube can become as a cube root here, or what is going to be the volume of soil. Now, you can either take it in the percent side. So, here's volume of soil is 75% of this 325, and you don't need to do the calculation. It will get cancelled 3258, and the total volume of the holder will be 100% of 3258, which is equals to h1 we need to find out, and the actual height of the pyramid is 12 root 2. Right here it is cube. Now here if you'll see, we don't need to calculate because it will get cancelled. You will be left with 0.75. If cube comes to this side, it will become cube root of 0.75 equals to h1 by 12 root 2. Now if you transpose, h1 will be 12 root 2 times cube root of 0.75. You can calculate the volume also 75%, and you can repeat this step. You will get it as 15.418 centimeter will be the height. Now this question is based on cone. So your pyramid and cone both are the very important figures from the exam perspective. Here if you will see what is given in this question, you will make calculation to help the community design a rooftop garden to grow the tomato plants, right? Tomato plants are grown in a pot. The pot is truncated cone. What is the meaning of truncated cone? It's called frustum of the cone, right? So here frustum of cone means it is cut from the bottom. So that's called truncated cone. Now, whenever you have this, you need to remember the similarity also. If you'll see here, if you'll see this figure, right? This is the from the bottom it is removed. So sometime you have to remember there is a similarity because there is a big triangle and small triangle. So you need to remember here whenever this is the height, slant height. So if I take here small s by capital S will be equals to small height by capital height means bigger height, height of the bigger cone will be equals to small r by capital R. This is because corresponding these two triangles are always going to be similar. 90-degree angle, here also 90-degree angle, and this is going to be the common angle. So remember here the ratio of their corresponding dimensions are always going to be equal. I have taken small letters for the smaller cone and the big letters for the bigger cone. So this part also I have to remember. In this question, what else is given here? Here it is cut from the bottom, so this is called truncated cone or frustrum of the cone. And whatever cone is removed, the volume they have given. Sometime you need to calculate this volume. So what do I need to find out here? So this is the volume of a pot. Calculate the volume of a pot. So whenever this is there, how will you calculate the volume of a pot? This is a big cone here. So from this big cone, if I remove the small cone volume, you will be left with pot volume. Volume of pot is going to be volume of big cone here, because the of big cone minus volume of small cone. Volume of small cone. Now what is going to be the volume of a cone? 1 by 3 pi r square h. I, what is your R? If you'll see the first figure here, R is given as 15 and height is 240. So it will be 15 square times 240 minus, what is the small cone here? Small cone volume is already given, 32,720. So it is going to be minus 32,720 as 56,548.67 minus 32,720. 23,828.67. Now, what is given here? You need to give your answer to the nearest tens, right? 10. So, what is the 10th place here? 2. Now, next value is 8. 5 or more, you need to add one more. So, this one will become 23,830 cubic centimeter is the volume of the pot. What is the given in the next part of the question? Now the pot will be filled with the soil till 90% of the maximum capacity, because the pot is not fully filled. So you will first find out here 90% of volume of the pot, which is 23,830, 23,830. You will be getting 21,447 cubic centimeter, right? Now determine the volume of in liters. Now 1 liter is 1000 cubic centimeter. So what do I need to find out? X liter is how much? 21,447 cubic centimeter. If you do the cross multiplication, you will get the answer. So X will be 21,447 divided by 1000, 21.447 liter. On this one, if we take, it is approximately here 21 liter of soil is needed. Now, what is it in here? Determine the total cost to grow one tomato plant in a pot. So, how to find out here total cost? If you will see, first 21 liter of soil, the soil cost is given as $0.4, so times 0.4. Then we need to add for the tomato plant, which is $6, so add $6 plus here one empty pot which is for $1.5, so we'll add that as well. It is going to be 8.4 plus 6 plus 1.5. If you will add everything, it will be 6 7. It is going to be $15.9. After this, what is written here? This community will grow their tomato plant in the pots, in pots in a rooftop garden, right? Each plant should have space around the pot here, so space around the pot for the plant to grow and for people to walk in between. The circular shape represents the space required for each plant, right? Now here it's written, the circular shape means the plants are here in these dots. So, and this circular means it is around this. These vertices are going to represent the plants. Here also these vertices are going to represent the plants, and circular shape is space between those plants. The circular shape can be arranged in different ways to make the best use of space available in the garden. So one is square shape, here another one is triangular shape. Here square arrangement, and here there is a triangular arrangement given. In the following question, you will make calculation to make the best use of the space available. So for first L1 is square arrangement and L2 is given as triangular arrangement, where you will see the radius as 40 centimeter. What do I need to find out here? Determine the length of square arrangement. Now here total length, if you will see, it is going to be this because it is always perpendicular here. So this is the vertical length. How much will be there? You can see that this is nothing but the diameter of the circle. So 40, 40, here also 40, here also 40. So that is why it is carrying only one mark here. So what is going to be the L1? L1 will be here 40 times 4, which is going to be 160 centimeter, the length of this arrangement. Now here for the triangular arrangement, find the length L2 for the triangular arrangement. Now here if you see, the weightage is 3 marks. So because here if I am taking, again I have to take the perpendicular length, the vertical length, which is till here. Right now here and this one, if I take this, this is nothing but R. This is also R. But how will you get this length? If I take that length as AB, in the triangle you get that perpendicular length. If I write down this as H, because what will happen, this is 40, this is 40, this is also 40, this is 40, this is 40, this is 40. So this is becoming equilateral triangle where 80 centimeter is the total length of each side. Now here this is the height of the triangle here. So each one, because it's equilateral triangle, either you can use trigonometric ratio or Pythagoras theorem. I am going to tell you both. If I use Pythagoras theorem, if this is triangle ABC, now in triangle ABC here you can see that AB is perpendicular on BC. Hypotenuse is AC, which will be 80 square will be equals to H square plus 40 square. So here H will be equals to 80 square minus 40 square, and this is going to be square root of that, as here root 40 800. H has become here 40 root 3. Now what is the extra length? You have to add 40 here and 40 down. So here L2 will be 40 root 3 plus 40 plus 40, that 9.28, and approximately it will be 149 centimeter for three significant figures. Whenever we are doing it, 40 root 3, you can write down here decimal value also, because later on if you need to use it, 69.3 here to 8 approximately, you can take it as 70 centimeter also. Other than this, I was telling you, you can use here trigonometric ratio also, because it's a equilateral triangle. So the angle is 60 degree. This half, it is 40 centimeter. This is the radius. So I can take opposite by hypotenuse or opposite by adjacent also. So if I take here opposite by adjacent, so tan 60, which is equals to H by here 40. So H will be 40 times tan 60. If you will do this, you are going to get the same values, approximately 69 or 70 centimeter also, we can take it as the maximum. Now after that, what is given here? Design a rooftop, because here now F part is having your 10 marks, right? Now what are the possible design? You can do it here, square arrangement or the triangular arrangement. What is given here? Design a rooftop garden to grow the tomato plants. Your design should make best use of all the rooftop garden space to grow as many tomato plants as possible. Then your answer should have three relevant factors. Based on that, you are going to design. So here if you see, they have given you the space where you have to take these circles to see that how the circles are going to fit here, right, in the square or triangular design using the dimension. So what are the three factors? If you will see here, the three relevant factor of your design will carry here 2 marks here. So you need to write down 3 factors. So first one you can write down here space, because there is you are leaving the space for plant to grow here. Plant to grow. Now, whenever you are taking that, what can be the possible answer here? You can have here distance between plants, because that's given here. Distance between here plants, and those two, distance between those two dots also here. Then area of the pot also, right? How much area of pot is there? Space for people to walk, space for people to walk. So anything you can write on here, people to walk. These are the, this is the all, everything is related to space for plant and people to walk. Then what is going to be the second factor here? Now here there is a garden. The dimension of the rooftop garden is very important, which is given as length as 360 and breadth as 290. So the second factor you can write down here, dimensions of rooftop garden. Now what is that rooftop garden dimension here? Length is given as 360 centimeter and width is given as 290 centimeter. This is the second factor. Based on that, how many plants can fit there, it's going to decide. Then here there are the different arrangement. Here you can see that there is a arrangement here, type of arrangement also, it is going to be the next factor here. Type of arrangement, whether it is triangular or the square arrangement. So type of arrangement, square or triangular arrangement. So based on that, these are the 3 factors, main factors. Based on that, here you will decide how many plants can fit in the rooftop garden. Now here it says you have to show the calculation for your design, but before that you need to try to see that how many draggable circles fit in this rooftop garden. So if you will see that these are the possibility here, I'm just giving you the answer. When you'll take these circles on that space, when you will drag it, you will get these one. You have to try to fit the maximum number of circles there, because here if I see this arrangement, if you'll see the number of circles are more, that means you can plant more number of tomato plants there in the available space. And here if you see in the triangular, this one you can fit the maximum number of tomato plants, right? So here if you see, look at here, this is the triangular arrangement, right? This is the extra, again this is overlapping triangle, this is again triangle, this is this triangle. Then here if you'll put it here, this is also a triangular shape, right? This is also triangle. So when you are putting here in this triangular shape, you are able to use the maximum space and you can plant the maximum number of plants. Now here if you will see, this is 15 plants can fit in that rooftop, and here there are 16 pots can fit. So 15 to 16 maximum pots can fit. This one, if you'll do it, you will lose marks because you're wasting your space. Then after this, your calculation, you have to show it, because you can see that here the triangular arrangement is you are able to fit more number of plants. So because that's an arrangement. But if I need to do it using calculation here, what is the calculation I'll see here? Now you need to arrange it. When you are doing this, you need to first find out how will you do the calculation. Now you know that this length is here 360, whereas this width is 290. Now in your, if you see this, whether you are taking this total length was here, it was 69, correct? And this one was extra, which is 80. From here to here, it was 69. From here to again here, it was 69. So what can I do here? Here you can show the calculation as in horizontal direction. Here in horizontal direction, because in horizontal direction there are two circles together. So how many of them can fit here? If you see if you are taking that here 360 divided by 69, because this total here it is 69, this is also 69 right here. So how much we can do it here? 69 to 70, because this length was here, if you'll see, 69 to 70. So we'll see here, whenever you are dividing by this 360 by 69 here, you can't write down as a decimal. So it's coming 4 point something, 5 point something. But I need to get here plus 80, because if you'll see in this arrangement here, the plus 80 was extra at the top and bottom, right? The middle part was 69. So that is why whatever I do, I have to do add 80, and then you can multiply here 69 by 4 here, because it will go as 4 times. Then you will be getting here 356, which is less than the horizontal length 360. That means on horizontal side here, you can fit here 4 circles, right? Now here similarly, if I take here 70 also, because if we do round up, you will see 280 plus this is exactly coming as 360. That means still there will be 4 circle on the horizontal side direction. Now if I consider the vertical direction, if I'm taking here vertical direction, now in vertical direction also, if I'm taking it here, you can see here 1, right? Then again here, this is 2, and in between 80, you have to see that. So again, that means in vertical direction also 290 divided by 69 and 70, you can do it here. 69, if I do it here, 360 by 70 here I was doing. You will see that again you have to do plus 80, right? And if I'm doing here this one as 3 times, you will see it will go, and that is coming it as 287, which is less than 290. If I take here 70 also, then you are getting here 3 times this plus 80, which is the extra length, which is exactly coming as 290, right? So this is the way we do the calculation, and how many maximum number of this one, if you what is the maximum number of circles or plants can fit there? So to 16 pots, right? Other than that, whenever you are calculating, if you remember in the earlier part, we have done how much will be the cost of each part. And the another factor was cost also, right? Here the cost of the plant is also, you can take it as the type of arrangement here, and the cost also you can take it. So what are the maximum number of pots can fit here? 16 pots. So if you are taking cost 16 times, now what was the total cost to maintain the one here, one tomato plant? Along with this, the total cost was $15.9. So we can do here $15.9, we can do round up to $16. So it will be approximately here $256. If you are taking here 16 times, later on also you can do the rounding of $200, 254.4, which is approximately $255. Approximately you can write down answer as $260 as well. Now, after calculation, it's written here justification also. So you need to write down here, how do you justify your calculation, arrangement, everything is accurate, right? So you need to write down here reason in words here. What did you do? The first one here, when you were doing the arrangement, this circular arrangement, you have considered the length and width of the rooftop garden, right? So here, what you will write down here, have considered the, I have consider all the requirements. What was the requirements here? There has to be space between the pots. What is the rooftop length and breadth that's given here? So whenever you are putting circles or those pots, circular faces on the canvas, means you are considering that requirement. Then here, if you are taking, we did not consider the square arrangement, because when you are doing square arrangement, we are getting only here 3 rows. We have taken this part, this design, 16 pots design here, right? 16 one, because the how many rows you have able to do it, this is the triangular arrangement, whereas here this is the in the square arrangement, they were able to take only 3 rows, right? So this one was 3 rows, whereas in triangular arrangement, you were able to take the 4 rows. So you can write on here if they were square arrangement, arrangement, uh, then it takes only 3 rows, but in triangular arrangement, triangular, see justification, you have to write down all the reasoning. In triangular arrangement, then I was able to fit 4 rows. I was able to fit 4 rows instead of 3 rows. Then what could be the next reason here? Now here the estimated, because accuracy was given here, so space for plant to grow is an estimation here, right? Space, because you can't take the exactly point decimal value. So here space for plants to grow is an estimated value. That's why we have in between, we have done the rounding off. Now some plants may not need the exactly same space to grow, because some plants they grow slow and other plants they grow fast, right? So here uh, plants might, though they have given the exactly same space, we have to leave it, but maybe some plants need extra or less space. So here plants might not need exactly same space to grow. Same space to grow. That also can be justification, right? Though we have left the space, but every plant may not need the same space. The price of soil can be less, because if you are buying in bulk, the price of soil can be less if we buy multiple liters, multiple liters, or price of plants can be less if there are multiple plants. If multiple plants are there. That means if you are buying in bulk, right? If you are buying the soil or plant in bulk, the cost may decrease. So these are the pointers you need to write on in the justification. Hope you got this.
Thank you for watching this video. Please like, share and subscribe. Also, keep practicing.